Hello and welcome to In Depth. I'm Tina Jha. On 8th October, the Royal Swedish Academy of Sciences announced the 2019 Nobel Prize for Physics. 3 scientists have been awarded the prize this year for their contribution to the understanding of the evolution of the universe. One half of the prize has been given to Canadian-American scientist James Peebles for theoretical discoveries in physical cosmology, while the other half has been given jointly to Swiss astronomers Michel and Didier Queloz for their discovery of an exoplanet orbiting a solar-type star. The laureates will receive the award at an elegant ceremony in Stockholm on the 10th of December, which is the anniversary of the death of prize founder Alfred Nobel. Today on the show, we'll talk about the pioneering work of the 3 Nobel laureates in exploring the evolution of the universe and discovering a new kind of planet, and how their research has transformed our ideas about the cosmos. The Nobel Prize in Physics for this year has been awarded to 3 scientists who have made major cosmic discoveries. The winners, James Peebles, Michel and Didier Queloz, were named at a ceremony in Stockholm on the 8th of October, where their work on planets and the Big Bang earned them the prestigious prize. James Peebles, born in Canada, will share the award with Michel and Didier Queloz, who are both Swiss astronomers. The laureates will receive the Nobel at an elegant ceremony in Stockholm on the 10th of December.
This year's prize goes for contributions to our understanding of the evolution of the universe and Earth's place in the cosmos.
3 scientists have won the 2019 Nobel Prize in Physics for groundbreaking discoveries about our universe. Scientists James Peebles, Michel and Didier Queloz were announced this year's winners at a ceremony in Stockholm on 8th October. The Royal Swedish Academy of Sciences have chosen the 3 scientists for their work in understanding how the universe has evolved and the Earth's place in it. One half of the award is for James Peebles for his theoretical discoveries in physical cosmology, and the other half is for Michel and Didier Queloz for the discovery of an exoplanet orbiting a solar-type star. An exoplanet is a planet outside our solar system. The winners will share the prize money of 9 million Swedish krona, a gold medal and a diploma.
The Royal Swedish Academy of Sciences has today decided to award the 2019 Nobel Prize in Physics with one half to James Peebles for theoretical discoveries in physical cosmology, and the other half jointly to Michel and Didier Queloz for the discovery of an exoplanet orbiting a solar-type star.
Canada-born James Peebles was honored for his contributions to the understanding of the evolution of the universe and Earth's place in the cosmos. With others, he predicted the existence of cosmic microwave background radiation, the so-called afterglow of the Big Bang. By studying the CMB, scientists have been able to determine the age, shape, and contents of the universe.
Some of it will go to charity. Some will go to our children. I must say, I owe a lot to the University of Manitoba, and a chunk will go to it. In cosmology, we're invited to apply that same theory, extrapolated to scales that are about 10 to the 15 times larger. Spectacular. Why in the world should you assume that the same physics would apply on those scales as in the solar system? I was nervous about that. I was nervous about the lack of evidence about the nature of the universe. But the evidence kept appearing. It was quite a joyride.
In October 1995, Michel and Didier Queloz announced the first discovery of a planet outside our solar system, an exoplanet orbiting a solar-type star in our home galaxy, the Milky Way. This discovery started a revolution in astronomy, and over 4,000 exoplanets have since been found in the Milky Way. Strange new worlds are still being discovered with an incredible wealth of sizes, forms, and orbits. They challenge our preconceived ideas about planetary systems. Reacting to the news, Swiss scientist Didier Queloz said, "The minutes after finding out he had won the Nobel Prize were extremely intense."
My first reaction, I wasn't even sure it was not a joke. So I said it's a joke, and as it's true, and then I could not think at all. I had a complete blackout for a couple of minutes because emotionally it was extremely intense. We all know, I mean, scientists, Nobel Prize is a pinnacle of science, and frankly, I was not expecting that.
Oui, que j'ai appris la nouvelle un peu par chance en me connectant à Internet, que j'étais dans les heureux récipiendaires de ce prix cette année. Évidemment, c'est un certain choc parce que, comment dire, même si on en rêve à certains moments.
While James Peebles' theoretical discoveries have contributed to our understanding of how the universe evolved after the Big Bang, Michel and Didier Queloz have explored our cosmic neighborhoods in the hunt for unknown planets. Their discoveries have forever changed our conceptions of the world. This was the 113th Nobel Prize in Physics, awarded since 1901, of which 47 awards have been given to a single laureate. Only 3 women have been awarded the Physics Nobel so far: Marie Curie in 1903, Maria Gopher-Mayer in 1963, and Donna Strickland in 2018. Bureau Report, Rajya Sabha TV. The 2019 Nobel Prize in Physics rewards new understanding of the universe's structure and its history, and the first discovery of a planet orbiting a solar-type star outside our solar system. In this report, let's take a look at the pioneering work of these 3 scientists who have been awarded the Nobel Prize for Physics this year. The 2019 Nobel Prize for Physics has been awarded to 3 scientists: Canadian-American James Peebles for his theoretical discoveries in cosmology, and Swiss astronomers Michel and Didier Queloz for finding an exoplanet that orbits a sun-like star. 84-year-old James Peebles is the Albert Einstein Professor of Science and Physics Emeritus at Princeton University. Born on 25th April 1935 in Manitoba, Canada, Peebles received his BS from University of Manitoba in 1958 and earned his PhD in physics from Princeton in 1962. He taught at the university for his entire career. Peebles was an instructor and researcher in the early 1960s, became an assistant professor in 1965, associate professor in 1968, and full professor in 1972. He received emeritus status in the year 2000. Over the last 50 years, Peebles' insights into physical cosmology have enriched the entire field of research and laid a foundation for the transformation of cosmology from speculation to science. His theoretical framework, developed since the mid-1960s, is the basis of our contemporary ideas about the universe. Peebles is credited with developing the theoretical tools that allowed scientists to perform a cosmic inventory of what the universe is made from, showing that ordinary matter makes up just 5% of its known contents, with the rest being dark matter and dark energy. For his outstanding contributions, Peebles has received dozens of honors, prominent among them being the 2005 Crafoord Prize with fellow Princeton astrophysicist James Gunn, also from the Royal Swedish Academy of Sciences. In 2004, he received the Shaw Prize.
James Peebles, he had a pioneering role in establishing the precision test in cosmology. When he was young, he was associated with the brilliant theoretician as well as an experimentalist, Robert Dicke. And Dicke himself was interested in finding out about the existence of cosmic microwave background radiation. But then it was in 1964, Penzias and Wilson, they serendipitously found out the existence of the relic cosmic microwave background radiation. That is a relic of the hot Big Bang origin of the universe. Since then, James Peebles, he has been working on how to establish from the observed microwave background radiation very precise and accurate results concerning hot Big Bang theory. James Peebles, he laid down the very quantitative aspects of physical cosmology that can be used in conjunction with the astronomical observations to give relatively precise way of describing the origin and evolution of the universe.
The other two physics Nobel laureates, Michel and Didier, have explored our home galaxy, the Milky Way, looking for unknown worlds. Michel was born in 1942 in Lausanne, Switzerland. He completed his PhD in 1971 from the University of Geneva and currently teaches at the varsity. While 1966 born Didier teaches at the University of Geneva and the University of Cambridge. Younger to Mayer, completed his PhD in 1995 from the University of Geneva. In the early 1990s, when Didier started his research career at the University of Geneva, Michel had already spent many years studying the movement of the stars, constructing his own measuring instruments with the help of other researchers. At that time, the search for exoplanets was not part of mainstream astronomy. But Mayer and focused their research on looking for unknown worlds in the Milky Way. They spent several months refining their results, and in October 1995, they made the first discovery of a planet outside our solar system, an exoplanet orbiting a solar-type star, 51 Pegasi. The pair's discovery came as a surprise to the astronomy community. The planet they detected, called 51 Pegasi, is a gas giant, a type that astronomers had expected would orbit the outer reaches of a solar system. But the pair found it orbiting around 10 times closer to its star than Mercury is to the Sun, an early sign that other planetary systems might not be like our own. This discovery started a revolution in astronomy. Since then, more than 4,000 exoplanets have been found in the Milky Way. Both Mayer and challenged the preconceived ideas about planetary systems and forced scientists to revise their theories of the physical processes behind the origins of planets. They pioneered the path that will allow us to eventually find an answer to the eternal question of whether other life is out there. It's because of them that we know today that about a quarter of all stars have a planet of Earth size and surface temperature, with the potential of hosting liquid water and the chemistry of life on its surface. Bureau Report, Rajya Sabha TV. Cosmology can be a difficult discipline to get a hand on, as it is a field of study within physics that touches on several areas. So what is cosmology? What do the people studying it actually do? And what is the evidence that supports their work? Let's understand these in our next report.
Cosmology is a branch of astronomy that concerns the study of the origin and evolution of the universe from the Big Bang to today and on into the future. It began as a branch of theoretical physics through Einstein's 1917 static model of the universe and was developed in its early days, particularly through the work of Lemaitre. As recently as 1960, cosmology was widely regarded as a branch of philosophy. It has since transitioned to an extremely active area of mainstream physics and astronomy, particularly due to the application to the early universe of atomic and nuclear physics on the one hand, and to a flood of data coming in from telescopes operating across the entire electromagnetic spectrum on the other.
Discovery is of an exoplanet around a star called 51 Pegasi. Okay, this star is a very huge giant gas star. So this star had a companion star, companion planet I mean, that planet was going around. So when two objects are attracting each other, what will happen is that this bigger object will not go around the smaller object, but will be wobbling. I mean, there will be a point here where it will be like, suppose if I hold this and then rotate like this, and holding in center and rotating and holding here and rotating, there is a difference, right? So like this, it will be in a different point, not in the center. That's called the common center of gravity. So that wobble will mean that sometime the star will be coming toward the Earth, sometime the star will be going away from the Earth. So when the star is coming toward the Earth, the light rays, because of what is called as a Doppler effect, which we can also see when an ambulance is going. When an ambulance is coming near you, the pitch is going up. When the ambulance is going away from you, the pitch is going down, right? In the same way, when the star is coming towards you, there will be something called blue shift. The lines of elements will be shifting towards blue. When it is going away from you, there will be something called as red shift. From this, you can know that the planet is actually wobbling. So they made that kind of a very precise computation, and then they found that there is a planet of certain size, larger than Jupiter, which was going around in 4 days.
Present models of the universe hold two fundamental premises: the cosmological principle and the dominant role of gravitation. Derived by Hubble, the cosmological principle holds that if a large enough sample of galaxies is considered, the universe looks the same from all positions and in all directions in space. The second point of agreement is that gravitation is the most important force in shaping the universe. A number of cosmological theories satisfy both the cosmological principle and general relativity. The two main theories are the Big Bang hypothesis and the steady state hypothesis, with many variations on each basic approach. The steady state theory says that the universe expands, but new matter is continuously created at all points in space left by the receding galaxies. The theory implies that the universe has always expanded with no beginning or end at a uniform rate, and that it always will expand and maintain a constant density. The Big Bang theory says that at the beginning of time, all of matter and energy in the universe was concentrated in a very dense state from which it exploded, with the resulting expansion continuing until the present. This Big Bang is dated between 10 and 20 billion years ago.
I think it's a very important discovery because for the same claim 400 years ago, Bruno was burnt. No, Bruno said that all the stars that we see in the night sky are something like sun as a planet like Earth going around it. These stars may also have a planet. So in some sense, for what Bruno was killed 400 years, we have found the truth. There are planets around other stars. Now we know close to about 4,000 planets. We have confirmed more than 4,000 planets, and there are something like a few thousands of planets which are candidate, meaning we don't have enough evidence to make a claim, but there are things like this. So a planet is also very important because it also shows that in addition to a planetary system for sun, there are planetary systems elsewhere. So which means that there can be life elsewhere, maybe intelligent life someplace. So it opens up a very different view of the universe. These two discoveries about fundamental nature of our universe as completely changing our view of the universe, even about 60-70 years ago.
The earliest pre-Ptolemaic theories assumed that the Earth was the center of the universe. However, with the acceptance of the heliocentric or sun-centered theory, the nature and extent of the solar system began to be realized. The Milky Way came to be called a galaxy and was thought to constitute the entire universe, with the sun at or near its center. Modern estimates show the size of galaxy to have a diameter of about 100,000 light years, with the sun near the edge of the disk, about 28,000 light years from the center. And the universe is born out of a cosmic explosion 13.8 billion years ago. The crux of today's cosmological paradigm is that in order to maintain a mathematically unified theory valid for the entire universe, one must accept that 95% of our cosmos is furnished by completely unknown elements and forces for which there is no empirical evidence. Bureau Report, Rajya Sabha TV.
One of the projects that keep space agencies busy is the search for the existence of life beyond Earth. Scientists have catalogued thousands of exoplanets orbiting distant stars that fit the basic requirements for life as we know it. But what is an exoplanet? Let's find out the answer in this report.
An exoplanet or extrasolar planet is a planet outside the solar system. In other words, it is a planet orbiting a star other than the Sun. For centuries, scientists, philosophers, and science fiction writers suspected that extrasolar planets existed. The first evidence of an exoplanet called Van Manen II was noted as early as 1917, but was rejected by astronomers. The first scientific detection of an exoplanet occurred in 1988. Shortly afterwards, the first confirmation of detection came in 1992 with the discovery of several terrestrial Mars planets orbiting the pulsar PSR B1257+12. Also named Lich, it is located 2,300 light-years from the Sun in the constellation of Virgo. The first confirmation of an exoplanet orbiting a main sequence star was made in 1995, when a giant planet was found in a 4-day orbit around the nearby star 51 Pegasi. The planet is believed to be about half the size of Jupiter. Two more exoplanets, 70 Virginis and 47 Ursae Majoris, were discovered in 1996. In the decade that followed, at least 100 exoplanets were recognized. Besides exoplanets, there are also rogue planets that do not orbit any star. These tend to be considered as a separate category. The rogue planets in the Milky Way possibly number in billions or more. Because these planets are so far away, hundreds, even thousands of light years away, scientists mainly learn about them through remote observations using telescopes and other equipment. Some exoplanets have been imaged directly by telescopes, but the vast majority have been detected through indirect methods such as transit method and the radial velocity method. Most currently known exoplanets were found either by detecting the effect of the gravitational pull of the planet on its host star or by catching the planet as it passes in front of its star and slightly dims it. Launched into low Earth orbit in 1990, NASA's Hubble Space Telescope has not only discovered a variety of transiting exoplanets, but has characterized the atmospheres of some of them. Hubble continues to remain in operation, and in an incredibly exciting finding discovered water on an exoplanet for the first time this week. K2-18b is 8 times the mass of Earth and is now the only known exoplanet to have both water and temperatures that could be potentially habitable.
We thought that the Sun, Earth, all of them were existed and continue to exist forever. Today we know that how the evolution of universe has taken place. Popularly we call it as Big Bang. A lot of people would have heard about Big Bang. But the exact mechanism of that Big Bang and how do you know that it has actually happened? These are all important questions. To say something is fine, but to find evidence is what is important. What Dr. Peebles did is that suppose if you have a, let's say you heat water in a vessel and allow it to cool, you can calculate that after half an hour what should be its temperature. After, you can calculate that. The temperature will come down. So similarly he claimed that if there was a Big Bang and then it should have been really very hot, and over the 14 billion years, the time that the universe has been expanding, the temperature should have come to a certain point, and then that should be available as a background radiation in the universe. Wherever you are sitting, on all your sides, that background radiation should be there. It is there. So he found that that temperature should have come down to a level where the radiation would be in the cosmic radiation would be in microwave region, and people have been able to establish it as he had actually predicted.
Another skywatcher, NASA's Spitzer Space Telescope, launched in 2003, observes transiting exoplanets in infrared wavelengths. It is planned to be retired in January 2020. But NASA's Kepler Space Telescope, launched in 2009, introduced the modern era in planet hunting. Launched into an Earth-trailing heliocentric orbit,
Kepler was designed to continually monitor the brightness of approximately 150,000 main sequence stars in a fixed field of view for 4 years. Before its retirement in the year 2018, Kepler observed 530,506 stars and detected 2,662 planets during its 9 years of service. A newer NASA mission, TESS, launched in 2018.
In fact, I must make a mention over here that India has also launched its own satellite for such type of a research called astro satellites. Its purpose and expanse are slightly lesser, but India is also very keenly looking at astrophysics in a very constructive fashion and using satellite technologies for it.
Since the first detection of exoplanets in 1992, scientists have identified 4,031 confirmed exoplanets, some of which show signs of having atmospheres. In addition to confirmed exoplanets, there are thousands of potential exoplanets as well. Out of the confirmed exoplanets, scientists list at least 21 planets that have the best chance for life beyond our solar system. Bureau Report, Rajya Sabha TV. So that's it from us today in depth. We'll be back same time tomorrow with a comprehensive view on some other subject. In case you missed the television broadcast of the program, you can also watch it online on YouTube and Twitter. And you can also send in your feedback and suggestions about the program. Thank you very much for your time.